Good morning. My name is Sean Gallagher. I am a senior threat researcher at Sophos Labs. Last time I got to speak at Texas Cyber Summit, which was in person a few years ago, I was the IT and National Security Editor at Ars Technica. Glad to be back. Wish I could be there in person, but that's how things are these days. Today, I want to talk to you about how malware and other malicious actors can abuse Google Docs and other legitimate services. We've seen a rise in this type of behavior over the past year or so, and there's some interesting aspects of this that you should be aware of if you're a blue team member, and if you're red team, here are some things you can learn to exploit to make your defenders' lives a little bit more miserable. So the defining reason why malicious actors use these legitimate services is because they're free. Why buy or steal or hack a C2 together from components you have to manage yourself on various services, a private server, things like that, when you can ride for free on Google Docs or any of these other legitimate services and get the benefits of using them as part of your activity. Since they're legitimate services, well, there's a number of advantages that come along with using them. For example, they're all TLS protected. So unless you have some form of SSL introspection or proxy running at your firewall or on your other systems to allow inspection of traffic going across the wire, you're not going to see any of this malicious traffic. They're free, as I mentioned. You can easily set up an account on any of these services and easily burn that, as I stated here. Once you lose an account, you can set up a new one, and it's easy to quickly migrate what you've done over to another service login, or even another service entirely. And because they are legitimate services, the hosts that they reside upon are generically trusted by most organizations, and that means that you have less likelihood of being blocked when you're doing an initial compromise or when you're launching malware for the first time. And once those URLs associated with your malicious activity are caught, you can easily just burn them and move on to another set of infrastructure using the same platform in a different account, new IDs. And because these services are so commonly used across organizations, they're not going to wholesale block these domains. So we did a little bit of research this year, early in the year, to take a look at how much of malware activity was based on TLS. And that's when I discovered that a huge proportion of the malware call home traffic that was linked to TLS traffic was going to Google Cloud. And we decided to dive a little bit deeper into that and found that this wasn't all Google Cloud, but across the board, we found that many of these call home destinations were tied to legitimate services that were being exploited by malware in some form. In some cases, it was based on spam that was trying to do phishing attacks. So they were really just links back to phishing sites. Some of these were running within a Google app or running in Google Forms, as I'll discuss in a little while. But a vast majority of it was actually going and grabbing data from a remote location on a Google service or on other services that use Google's infrastructure. Again, it was only 9% overall of TLS traffic from malware, but that does not include other forms of communications that we looked at. So, there are very few downsides for using legitimate services as part of your infrastructure for your malware operator. You could get your account or your IP address blocked as a result of the activity if it gets reported. If it gets caught by malware protection services, it could be added to a list of a bad reputation list and prevent further abuse. of that URL associated with your infrastructure. The content can be reported and removed if it's on the services where it's not clear who posted the content, because in some cases it isn't. But all of these are not really a problem for malware operators, especially since these accounts are fungible. You can create a new account and move on. So these are the types of legitimate service abuse we see the most, and they cover all the bases. From standpoint of hosting, you can store anything you can base 64 encode, or even raw encode in some cases, raw executables in some cases. Anything you can put into these environments can be used and referred to directly by URL in delivery of malware, either components, scripts, or other elements such as keys, IP addresses for communication, kill switches that prevent certain functionality from working. These can all be stored in documents or in files stored in these services. The same goes for exfiltration. There are APIs available for creating documents that will act as a phishing site. And in some cases, the services themselves can be used for phishing, for example, Google Forms. Also, there are other ways to tie content into these services that allow for spoofing of logins to collect that information, as well as other PII. But what's more interesting is that we are seeing the increased use of these services for the programmatic export of system data and user data. So in these cases, malware can read local system data, execute PowerShell commands or other commands, NWMI commands to grab information about the user, export hash tables, export cookies, export other data from browsers that they may be able to grab, and put them all into some form that can be posted via an HTTP post or directly written through an API to a remote document or remote storage. And the third way is messaging. So we have seen many of these services used for synchronous or asynchronous communication of information to and from malware. We've seen the APIs used for delivering notification of success of installation of malware, as well as other data collected by malware in the exfiltration phase. And we've also seen messages going the other way from operators to malware, sending changes to hosting information and to the Exfil locations, or changes to gateways for tools to connect to. These are all can be done in ways that are not necessarily observable by people who are just casually observing the documents or services that these are connected to. In some cases, these services provide an entirely private communication channel that is isolated from the rest of the users of the service. So, as I mentioned, Google Docs and other Google services are something we saw as one of the more frequently used services in malware activity. But these four services account for the lion's share of malicious activity on legitimate services that we've observed so far. They are not by any means the only ones. We have seen abuse of other services, including Slack and other collaboration platforms. But generally speaking, these are the top four. So Google Docs, Discord, which you may be familiar with, Pastebin, and Telegram. Google Docs, widely used by organizations, especially right now in pandemic times. There are many organizations that have gone to Google Docs as their default desktop collaboration environment. Discord also has been picked up by many organizations as a collaboration environment and is widely used in gaming and by people in other communities. Pastebin, well, it's been abused for quite some time in many ways, but it's also heavily used in collaboration space and used amongst developers. And Telegram. Now, Telegram is a freedom of speech oriented communication service that it hosts communities, and as we've seen recently, it's started to host a number of communities that have been pushed out of other social media environments, but it's also being used for legitimate purposes by organizations because it's free and it's secure end-to-end when using the client, and it allows organizations to have channels of communication that are redundant and won't be observable in theory. So for the most part, we see these services not being blocked by organizations. Pastebin might be more frequently, but we very seldom see any of these services blocked by organizations. Telegram, in particular, it has a very sophisticated API that can be used for bots. We've seen that bot API implemented by a number of remote access tools, things that steal information off of devices, and including Toxic-Eye, a particular flavor of rat. We've also seen it used by Raccoon Stealer and other rats, as well as other malware. You can use this messaging infrastructure to do things like sending messages, but it also allows for file transfers, as I'll show in a moment. And we've also seen communication not through actual messages, but through channel names and descriptions within Telegram, allowing just simple web scraping of data out of a Telegram channel to change the behavior of malware. Also, since we've seen more use of Telegram by communities, there's the opportunity for malware distribution through social engineering. So you can upload files up to 50 megabytes. They can be zipped and advertised as documents. And if they can be delivered either by private message or in a channel, and it's depending upon who the audience is and what it's labeled as, you can spoof what the content is and get people to download them and distribute your malware. So this is the send document API for Telegram. You can, as you can see, they have a rich API for sending documents. This allows not only for a document to be uploaded, but once it's uploaded, it gets a URL. So it can be used both for exfiltration by a bot. So a bot could collect data on the local system, put it into a file and upload it and send it as a message back to the malware operator. Or it could simply be uploaded into a channel, and then it becomes a URL that can be scraped out and used by other bots. In the case of Telegram, or pardon me, in the case of Raccoon Stealer, we saw Telegram channel descriptions used to advertise the changing address of the C2 gateway for exfiltrating data. So as you can see here, we have an older, to the right, there's an older grab from a web archive of this particular Telegram channel. And then to the left is a more recent grab of the same channel from a client. And as depending upon the activity of the rat, or as the infrastructure changes, the Raccoon Stealer operators can push out these encoded host addresses for their C2 gateways to redirect where the malware sends data. Now, Raccoon Stealer is a stealer as a service. So these gateways are operated for multiple attackers. Raccoon Stealer sells the malware as a subscription service to people who are looking to steal credentials. They deploy it in various ways, and the back end connects through this Telegram channel's address to a gateway that connects to a Tor panel that the attackers can look at to collect their data. So the next service up for grabs here is Pastebin. Again, you can, if you create an account, you get an API key. So it's a free API. You can programmatically export data from a script to create a new paste. So you could directly paste contents of a hash table, things like that, to a document on Pastebin. You can also easily scrape raw text by requesting the raw version of a page to get ASCII get scripts and download them. That allows you to execute directly once they're written to disk. And like the other services, it's all HTTPS, so there's no reading of the content by firewalls or other malware protection. So we've seen a number of bad actors using Pastebin as part of their activity, and in this case, this is a ransomware operator who was loading a batch file up to Pastebin as part of their activity, and they would retrieve this directly off of Pastebin for deployment on their targets. To the left is another set of data that was found on Pastebin associated directly with this group. They are dotless IP addresses that were used for exfiltration. So Pastebin is different from some of these other services in that there are many clones of this service. We've seen a number of Pastebin-like services pop up. They all have legitimate users as well as illegitimate ones. We've seen a particular amount of malicious use of Ghostbin, for example, as part of different malware campaigns, including the Raccoon Stealer campaign. These pop up daily. There's open source code available for these. So if you do want to invest in running a private server, you can take the open source code for one of these services and create your own. And to the eyes of everyone else in the world, this is a legitimate service, but it's simply it can be used as a private exfiltration platform. So let's talk about Discord a bit. So Discord's popularity has skyrocketed over the past few years. It's big in the gaming community. It is also increasingly used by organizations as a communications platform. Easy to set up a private server in quotes here, because it's just an instance, a VM instance within their environment. These run within the Google Compute infrastructure. So they show up as Google when we look at malware call homes that are referred to. Because you can set up a private server, it means there's virtually no external moderation on them. You moderate your own platform in Discord. That means that you can have any kind of activity going on there that you want, as long as you aren't inviting new users into it who will complain. And if all of your users are bots, that's going to be simple. However, on the open servers, on open public servers, community servers, we've seen a great deal of social engineering going on for deployment of malware. So in channels related to gaming, we see people dropping malware as files into chat, telling people that they're used for improving their game performance and things like that, as well as other social engineering spoofs. We've also seen the bot APIs for Discord being used by malware to communicate back to the malware operator in a Discord channel. And once you post a file into chat in any Cloudflare, in any Discord environment, it becomes a Cloudflare CDN delivered URL. So everything goes to cdn.discordapp.com, and which front ends a Google storage environment. It's through Cloudflare. And so you have an instant URL that can be referred to by malware to retrieve and download components. This means that you can use a private server as essentially a staging ground for malware and malware components, as well as a place to store exfiltrated malware, exfiltrated data using the API. So when we went looking at what was going on in Discord, we found a lot of malware, actual malware, existing within the Discord environment. Over 18,000 instances, 18,000 samples of malware that were posted within a 6-month period. We've been working with Discord, providing them with data about what we found to help them clean up things. But we saw at one point as many as 8,000 new pieces of malware a month being posted into Discord. So it's sort of a whack-a-mole situation. Unless you're specifically looking for the malware or scanning it as it gets uploaded into your environment, which I believe Discord is moving towards, it's difficult to stay on top of the abuse of the service. One of the pieces of malware we stumbled upon linked to this domain, monster.casa. It actually has a JavaScript or a JScript executable JavaScript script that's at this domain that was being retrieved by a loader that was actually being distributed through Discord as well as through other places. The JScript executes some commands that steal information from the machine they execute on. So that included cookies, passwords from browsers, and Discord OAuth tokens. So they were stealing the accounts of Discord users in addition to other passwords and data off of the targeted machines. And it was then sent back through the Discord API to a private server. Google Docs is probably the richest of all these services in terms of the types of APIs and content you can push into this environment. It's also probably the one that's least likely to be blocked by an organization, since so many organizations are using Google Docs to begin with, and Google Mail. As a well-documented API, it's easy to use for abuse because you can just scrape and parse content from web reads, but you can also directly interact with the content of these services through the API, through scripts and executables. Google Forms in particular is really easy to abuse, as I will show later in this presentation, because it uses an HTML post command that you can identify the elements of once you set up the form, and then that can be put into any scripting language to use to take data that has been extracted and put into a spreadsheet backend. We've seen Google Docs, the word processing application, and Sheets used to host code for malware, as well as other things, as other components. And then we've seen Docs, Sheets, and Forms all used for data exfiltration. So Google Docs is easy to use for malware to retrieve data. There's a hard way and an easy way. You can use a Google Docs API if you want to dive into it. It's a very sophisticated API. There may be some limits on what you can pull down through the API in free mode, but it's very usable by malware operators if they want to get into programming it. Or if you want to do it quick and dirty, you can use any Google Docs source and download it directly in a format that can be parsed by your malware or your your unwanted application or whatever form you want it, your script, whatever. Just using this particular URL format. You can tell it we want text, CSV if it's a Sheets document, and it will download to the local device. You can then parse it using your local code. So for example, you use Python and pandas to go through a spreadsheet and extract individual cells as elements to be used in a script for malware. In this case, we found that an encryption key was being used by the Lampion Portuguese banking trojan. During the operation period of that trojan, this document was used during this campaign. It carried a key that activated the malware. The owner put it in trash, but it was still visible on Google Docs when we went looking for it in our telemetry. So this is just one way that Google Docs can be used. Now this was using a .text view of the format. So when it was loaded, it was raw text and it could be directly processed as a text returned by the malware, by the banking trojan itself. Here's a little more sophisticated use of Google Docs on the back end. Lockbit, during a campaign last October, was using a Google Sheets cell in a Spanish document to hide PowerShell code. And the malware that was in the loader was going directly, the loader, which was a PowerShell loader itself, was calling this cell of the malware and retrieving an additional shell command, executing more PowerShell. And this PowerShell opened up a backdoor that allowed the attackers to drop additional files and execute ransomware. Google Forms. So Google Forms is stupid simple, and it's being used in many legitimate ways by organizations, but it's also being used very heavily by people in the spamming world for data collection, and especially for phishing. So in this case, I went through some recent spam that we intercepted to looking for links to Google Forms, and I found two examples that are particularly stand up in particular. This one is targeting Microsoft Outlook users or MSN users, it says, but it was as a link. It tells the victim or the target that they need to go in and check their password and everything to ensure they continue to have their Microsoft account. And despite the fact that it says that this is a Google form at the bottom and that you should never submit passwords through Google Forms, we believe, based on the traffic we've seen, that people did actually use this form and fill it out. So despite all that that phishing training you're doing, it's still happening. Here's a slightly more sophisticated version of the same sort of attack. In this case, it's a pretty bare bones email. It looks like it's from an organizational administrator for Office 365. And again, it urges the user to click on the link to go to Google Docs to update their information to ensure they continue to have access to their account. Saying that they had received a request from the target to terminate their account on Office 365. So again, the bottom of this form says it's a Google form. The URL is docs.google.com/form/d/ whatever the document name is. And people are still going to click on this. It's inevitable. So there are two ways to do Google Docs exfiltration, aside from phishing. Again, you can use Google Docs API to write directly to a document. So you could have malware create a Google Docs document that contains all of the hashes, all of the encoded content that you pull out with malware to a document that can then be downloaded by the malware operator. Or you can simply use Google Forms with an HTML post to create a spreadsheet full of the data from all of the victims that you've hit with malware. And we've seen a couple of examples of exactly that. So this is an Italian malware. It was actually, we classified it as a potentially unwanted application. It advertised itself as a module to be added to your browser. In this case, it says it's checking Internet Explorer. When you run this, when this gets executed, it pops up this window. But one of the things it does is it sends a GET request to Google Docs to this specific form, and it posts the data that fills this form out without user interaction. And we've seen another couple of cases of this going on. In one case, it was some malware that was installing a set of coin miners that linked to a Russian language form that was exporting data that included the Windows driver for information about the driver, which video card driver was installed, and the screen resolution, so they could determine whether or not it was worth trying to use the GPU to do coin mining. Again, dirt simple. In that case, it was using a curl command to do so. So there was no specific, it was using local resources. It was using the curl script already built into Windows to execute that post. So how easy is this to do? Well, I'll show you how easy this is to do. So first step is to create a form in Google Forms. If you have a Google account, you make one up, create a Google account, and then go into Google Docs and create a form. And in this case, I just created a simple three entry form called "Tell Me About the Rabbits, George." And once you create this form, you can identify the form fields by an ID by looking in developer mode on Firefox or on Chrome. Then I executed a sample post to capture the form data that was being transmitted to verify those form IDs. And as you can see on the right, the transaction gave me the form data that was being posted as part of this, intercepted this with Firefox. And the first three are the form fields. And then there's some other data there that is honestly disposable. It doesn't necessarily have to be in the transaction. This is just part of a transaction from the form. But I've done it without these, and it's still successful. So next step is to take that method post and turn it into code. So I wrote a quick Python script to help me do the same transaction. It uses subprocessor to run PowerShell commands to grab data about the local system, and it dumps them into variables here. And then it creates a form response constructed from the data I grabbed and from the information about the form ID that I set up. And then it sends that request back to Google Forms. And I just had a print there to make it work. This can be done easily with curl, can be done with PowerShell. I've been working on a PowerShell version to pull this off even more effectively and filelessly. But it works, and it's clean and simple. And as you can see from the next slide, the output is a little rough because it was pulling the exact console returns from these PowerShell commands. in text form and dumping them in as part of a form entry. But it gives me I got a lot of data about the local system. If I wanted to, I could have gone looking for cookies and things like that and posted them here as well. So really very simple to execute. And this is why I think we're going to see more of these types of attacks. We've seen several so far, but more of these types of uses of this service abuse as part of malware operations or as part of hands-on keyboard operations. Because why do you want to mess around with having to create files locally when you can just run a command that instantly exfiltrates all the data that you're trying to grab with the commands back to a legitimate service? The only way people would know what was going on is if they watched to see if there were requests to docs.google.com coming from their servers. So there are a lot of ways you can, on the malware side, make this work even better. You can do things like changing the user agent to spoof user interaction, make it look like it's the browser of choice on the user systems to avoid user agent screening when people are doing introspection. You can use field names in forms as a source of commands. So you can look at a form and not even interact with it other than to view it, and you could have kill switch information, encoded IP addresses, encoded URLs that are read by the malware as command and control. As I said, you can do this as a file, do this filelessly with PowerShell. And the real problem for defenders here is that I've seen a number of legitimate corporate applications that use a lot of these techniques already, use these services already in what would appear to be a malicious way. I've seen a lot of use of batch files and PowerShell commands that interact with Google Docs and other services that are being used by administrators to do things that you would think we would be doing in other legitimate ways. But because these methods help people get around company policy to do specific applications, they are being used for legitimate purposes, and therefore it's difficult for us to stop them. So with that, I am open for questions, and I hope to have a few of them from you. Look forward to having an open discussion with you about some of the other research we're doing. Look forward to an opportunity to come back to Texas Cyber Summit in person next year. And thank you for your time. I'll take your questions now in the channel.